Welcome to another tutorial video regarding principles of hydrostatics under fluid mechanics. This time, we will be solving the problem: if the pressure 25 meters below a liquid is 340 kPa, determine its unit weight, mass density, and specific gravity. But before that, don't forget to like, subscribe, and click the notification bell to support my channel grow. To continue, we first identify our given. We have the height, symbolized by h, to be 25 meters. The pressure, symbolized by letter P, to be 340 kPa. The required in the problem are the unit weight, symbolized by y, the mass density, symbolized by ρ, the specific gravity, symbolized by Sg, or for other references as S. After identifying the given and the required in the problem, we proceed with our solution. The first value that we are going to solve is the value of our unit weight. To solve for unit weight, we will use the formula, P is equal to the product Y times H, where P is the pressure, Y is the unit weight, and H is the height. However, we have to derive the formula to obtain unit weight. And we have now a formula for unit weight to be pressure all over height. We substitute values and we have unit weight is equal to the quotient of our pressure to be 340 kPa, all over the height to be 25 meters. We know that 1 kPa is equal to 1 kN per square meter. So, we have unit weight is equal to 340 kN per square meter all over 25 meters. We know that this is just the same as multiplying 340 kN per square meter times 1 all over 25 meters. We simply multiply and we have a final value for our unit weight to be 13.6 kN per cubic meter. The next value that we are going to solve is the value for our mass density. To solve for mass density, we will be using the formula, ρ is equal to y all over g, where ρ is the mass density, y is the unit weight, and g is the acceleration due to gravity. We already solved for the value of our unit weight, so we simply substitute values, giving us mass density is equal to the quotient if the unit weight of 13.6 kN per cubic meter all over the acceleration due to gravity of 9.81 meters per square second. We have to convert kilonewton to newton for easy solving. We use the conversion factor. 1 kilonewton is equal to 1000 newton. Kilonewton will be cancelled out, giving us 13,600 newton per cubic meter all over 9.81 meters per square second. Also, we know that newton is equal to kilogram by meter per square second. We cancel out the newton unit, giving us 13,600 kilogram by meter per square second per cubic meter, all over 9.81 meters per square second. We know that this is just the same as multiplying 13,600 kg by meter per square second per cubic meter to square second per 9.81 meters. Meter unit will be cancelled out. Also with the square second. We multiply and we have a final value for our mass density to be 1386.3405 kg per cubic meter. Finally, let us solve for our specific gravity, symbolized by Sg. To solve for its value, we will be using the formula, Sg is equal to ρ of fluid all over ρ of water, where ρ of fluid is the density of fluid and ρ of water is the constant value for density of water, which is 1000 kg by cubic meter. We substitute values and we have specific gravity is equal to the quotient of 1386.3405 kg per cubic meter all over 1000 kg per cubic meter. We simply divide and we have a final value for our specific gravity to be 1.39. That is now the solution to our problem. Don't forget to like, subscribe and click the notification bell before you exit.